This is a very quick overview of the MRS Cube Analysis notebook that we will be working on. The goal here is to extract spectral features from an IFU cube and measure some of their attributes. We are going to be using a simulated dataset for MIRI MRS for an AGB star, but this should work on real MIRI MRS data as well. The main focus will be on a collapsed spectrum or an extracted spectrum in our 1D spectral viewer SpecViz, although we will be looking at the data cube a little bit as well. There is another notebook that focuses more on cube analysis. The first thing we want to do is import all of these packages and define our environment and download the necessary data. Next, we are going to read the spectra in. It's important to note that right now the default pipeline outputs the spectra from the MRS observations as 12 independent spectra, 1D spectra, and 12 independent cubes corresponding to the different channels and subbands. You can read all of the individual 1D spectra into a single spectrum list that you can then load into SpecViz, which we will do. We also have some demo videos installed inside of the notebook. I will skip that. And you can see here your set of spectra ranging from 5 to 28 microns. We can zoom in just to take a closer look. And if we look at the drop-down, you will see the combined spectrum, but also all of the individual 12 spectra. So that's how you can read in from a spectrum list. Also, you might be interested in looking at the original cube, or at least one of the channels shown here. This is CubeViz, which is another instance of JWebbinar. You can see the flex viewer in the top left here, and the error viewer in the top right, and the collapsed spectrum from this cube in the spectral viewer at the bottom. You can look at sub-regions by drawing what we call subsets with regions, and you can see the collapsed spectra of those pixels in red. Of course, there's a lot more you can do. We're going to be going through a number of the tools in our drop-down toolbox today. But first, we are going to splice together all of our spectra and put them into what we call a single Spectrum 1D. Spectrum 1D is just the class of objects for SpecUtils package, which allows you to do all sorts of AstroPi analysis. It's important to remember that JWebbinar is built on the AstroPi functionality. Just to take a quick look at what that spectrum looks like compared to the original spectrum, we can just make a simple plot in Matplotlib. Nothing too fancy. There's a little bit of a difference between the simulated spectrum and our original input source. That's just due to our simulator. We don't have to worry about that. And then we can get our spectrum ready and open it inside of SpecViz. Okay, so here's our spectrum again. This time it is a spectrum 1D, right? It is not the spectral list, so that's just a little distinction. And one of the things we want to do to get started is we want to analyze this particular feature, and to do that we want to subtract off any continuum. And so to fit a continuum, we're going to open up our model fitting package over here, and we are going to define the continuum region. In this case, we sort of assume it's a black body background, and we're going to select a region over there in subset 1. But we can actually make 2 regions part of this single subset by using that add feature. And the part of the spectrum we're going to want to fit is subset 1, not the entire spectrum. And we're going to want to do that with a black body, which we have a component here called BB. We're able to manipulate that black body parameters if we want to guess for the initial fit. There are some defaults that are loaded. I usually like to start with 1000, especially for this object because I know it so well. And for our equation editor, we're just going to have a black body component. If we had other components, we could add them all together here. And we're just going to call this BB1 as our fit. And here we go. Okay, not so great, but that's just because we need to probably do a few more iterations for it to converge. Okay, so that's looking a lot better. So we can go down now to the rest of our notebook, where we can extract BB1, that model, okay, from our SpecViz window and continue on with the analysis. We can plot what that black body subtracted spectrum would look like, and you can see it here. Here's our fit, and here's the subtraction, and we've removed that continuum component exactly like we wanted to. That's great. Okay, so for the next part, we now want to do one more step. All right, let's look at this black body continuum subtracted spectrum. All right, and we want to remove a spline component, assuming there's this sort of spline component here, just so we can do a straight up analysis. And so we're going to do the same thing. We're going to draw a region. We're going to add a second part to that region. And again, we are going to just do a spline fit. And it's polynomial of order 2. Okay, we'll take the defaults. And let me just remind myself what I called this. I called it polyfit. This helps to know what I wrote this code as, and you can see we have a nice fit here. Okay, and we can extract that back into our notebook. And then we can remove the spline. See what that looks like. Okay, see, now we just have our good line. All right, and now we have our nice continuum subtracted line. We can draw, a region and zoom in on that, and we can open up our line analysis. You can see here. Let's do it on. Do the continuum subtraction subset, and you can see we're able to get the line flux, the equivalent width, the Gaussian full width half max, and the centroid, which is great. And you can also extract those measurements back out into your code and plot them, write them here, which is excellent. You can do analysis, and you can also check out your residual. It's not perfect, so here it allows us to go back and we can redo the modeling as much as we want in an interactive way. And so you can go on and on until you get this right, and then you have your code, and you don't necessarily need to work in the interactive tool any longer. You have a streamlined piece of code. So that takes us through the MRS SpecViz line analysis.